Piecewise functions. All right, so here's your standards, your success criteria. So today you need to be able to evaluate piecewise functions. You need to be able to graph piecewise functions and write piecewise functions. So these are the things we're going to be working on today. Here's a picture. You can see that this is 3 different lines on the same graph. This is considered a piecewise function. This has an open circle and this has a closed circle. So that means this point is not included where that one is. Same thing here, open circle, closed circle. So if you use the vertical line test, this does pass the vertical line test. So this would be a function. And because it's in different pieces, this would be something like a piecewise function would look like. This one right here is an example of a step function. Again, open, closed, all the way up through there. There's one open circle under the closed circle. So there's no points that repeat, no x's that repeat. So this would also pass the vertical line test. And a stepwise function is a certain kind of piecewise function, which we will look at just a little bit. All right, some vocabulary that you need to know. A piecewise function is a function defined by 2 or more equations. A step function is a piecewise function defined by a constant value over each part of its domain. So remember, a constant value, if you graph a constant, it is just a horizontal line. And a step function, a piecewise step function, is that same thing. So f of x equals 2 between 0 and 2. So your domain 0, 2, you can see that that's y equals 2. Y equals 3 from 2 to 4. From 2 to 4, you can see that it is up 3. So this is a step function. This is an example of one. So it's good to know what the function looks like and what the graph looks like. Again, this is just where it's defined on the domain. So when you have a piecewise function, you'll see that there are different pieces to the function. This is just the 2 equations, the 2 pieces, and then the part after the comma tells you where on the graph. So if x is less than or equal to 0, that means the left side of the graph. This is your equation for the first line. If x is greater than 0, x is greater than 0, so you're looking at your positive x's. So this function is defined, the second function here is defined only on the positive x's. So just a few things to look at as you go along. Example 1 says evaluating a piecewise function. All right, so if we evaluate f of x equals 3x plus 1 if x is less than 2, and we do x minus 5 if x is greater than or equal to 2. All right, so we have 2 examples here, x equals 2 and x equals negative 1/3. So the first thing you have to do is say, which piece of the function do I plug it into? So I'm going to look at the domain first. When x equals 2, this says when x is less than 2. This one says greater than or equal to 2. So I'm going to use this second function here for x equals 2. So just like any other equation, okay, I've got f of x equals x minus 5. I'm simply going to plug in 2 for x. So I'm going to say f of x equals 2 minus 5. And actually, if you want to put in the 2, that tells you that's the x value, and we're solving for f of x, which is the y value. So 2 minus 5 is negative 3. So that would be a point 2, negative 3, if you were looking for an ordered pair there. All right, B part, that's A part. B part says evaluate when x equals negative 1/3. All right, so this says if x is less than 2. Negative 1/3 is less than 2. So we're going to use the top function for B part, okay? All right, so the top function says f of x equals 3x plus 1. So we're going to have f of x equals 3x plus 1. All right, so we're going to have f of x equals 3. In place of x, we're going to substitute negative 1/3. And then plus 1. All right, so this is evaluating f of negative 1/3. So when I plug in negative 1/3 as my x, what do I get for my y? So 3 times negative 1/3 would be negative 1. Negative 1 plus 1 is 0. All right, so again, first look at this part after the comma. This is telling you where on the domain, what part of the domain this is graphed or the function is evaluated for. And then once you figure out which function to use, you simply plug this in for x and solve for y. All right, so I want you to pause the video, and it says to a self-assessment, you need to evaluate the function when x equals negative 8, when x equals negative 2, 0, 7/2, and 5. So you're going to have 5 answers because you have 5 inputs. So this is your 5 x's. Find your 5 y values. Remember, start by looking at each one individually and see which function to plug it into. Then solve for each one. All right, pause the video, come back in a few minutes to see if you solve these correctly. All right, so evaluate the function when x equals negative 8. Negative 8 is less than negative 2. So 3 is your answer here. F of negative 8 equals 3, okay? That is just a constant function there. That's your whole equation. That's just it. All right, so the next thing says when x is negative 2. Negative 2 is included here. So this says less than negative 2, but not equal to. So negative 2, so x is between negative 2 and 5. So I'm going to take negative 2. I'm going to plug it in for x. Negative 2 plus 2 equals 0. And then I'm going to take 0. Okay. 0 is between negative 2 and 5. So I'm going to use this same function again. So 0 plus 2 is 2. And then 7/2. So you can think 7/2 is the same as 3.5 or 3.5. 3.5 also falls between negative 2 and 5. So I'm going to do f of 7/2 equals this same function here, 7/2 plus 2. So this is 3.5. 3.5 plus 2 is 5.5. And then the last one says evaluate when x equals 5. All right, so this has x is less than or equal to 5. And this one says x greater than 5. There's not an equal sign here. So it's only included in the middle function. So once again, we're going to use x plus 2. So f of 5 equals x plus 2, or 5 plus 2. 5 plus 2 is 7. So you can see that we used the first piece once. We used the second piece 1, 2, 3, 4 times, and we did not use the last part of the piecewise function for this evaluation. That's okay. You have to look at the domain and see which part of the function you need to use. Hopefully you got those correct and you don't think that's too difficult. I kind of like piecewise functions, and I always hope that my students do as well. All right, example 2, graphing a piecewise function. All right, so we've already looked at graphing y equals mx plus b. So all we're going to do is graph two different pieces on the same page. All we have to do is figure out which part of the function we need. So this one says graph y equals negative x minus 4 if x is less than 0. So we know our x-axis is here. We know this is 0. So we're only going to graph the first line that represents to the left of 0. And then y equals x if x is greater than or equal to 0. So that means that line's going to be graphed on the right side of the graph paper. All right, then we have to find the domain and range of the piecewise function. All right, so let's start with y equals negative x minus 4. So it says if x is less than 0, not including 0, less than 0. So we know that this would be our y-intercept, negative 4. So negative 4 is down 4, 1, 2, 3, 4. But according to the domain, this point is not included. So we're going to put an open circle here to show that it starts there, but it's not included. That point is not included in this first function. All right, then it has a slope of negative 1. So you can think down 1 over 1. Oh, but you can't do that because why? I would be doing x is greater than 0. We need x less than 0. So think about how to use a slope of negative 1 to go left. So if I rise 1 and go left 1, that produces my negative slope. So I can go up 1 over 1. I kind of missed that point there. Let's see. All right, so up 1 over 1, and you can see that it's still going downhill. So it's still got that negative slope. So it's got a negative 1 slope, and that would be my line. So let's find a line here with an open circle at the end, and then graphed in this direction for however far. So that is the graph of y equals negative x minus 4 if x is less than 0. All right, now let's do the second part. It's called a piecewise function for a reason, because for this one there are 2 pieces. So now we need to graph y equals x, and this time it's going to be x greater than or equal to 0. So it has to be everything on the right side of the x-axis. So y equals x plus 0. There's no number here, so we can assume the y-intercept is 0. So since this is x greater than or equal to 0, we know that this one is a solid dot, a solid circle. This point is included in this function. All right, so there's no number here, so you assume it to be a 1. So we're going to go up 1 over 1, up 1 over 1, and we're going to continue using the slope to make those points. We can go back and find our arrow. Now we can make an arrow here. Well, I got off just a little bit. Let's see if I can straighten it up a little bit. There we go. All right, so if you use a pencil or a vertical line, you can see open circle, closed circle. This is the only one. Since this one's not included and this is included, your pencil test or your vertical line test will show that this does pass the vertical line test, which means this one is a function. All right, we are going to look at the next example, but I'm going to do that in the next video since we are running out of time. So join me in the next video to graph this one. If you want to go ahead and try it on your own first, please feel free to do so.